Hello, we are going to see about the Heisenberg uncertainty principle. The man in this picture is the Heisenberg, the great scientist and a German scientist. He proposed that uncertainty principle. Let us see what he said. So, according to the Heisenberg uncertainty principle, the exact position and the momentum of an electron cannot be determined with absolute accuracy. What does it mean? It tells that the accurate or the correct position and the momentum of an electron cannot be determined or we can measure with absolute accuracy. So let us see why. Before moving into this topic, let us know what de Broglie concept means. It's nothing but the concept says that every matter in this world possesses the dual nature. So with that concept, what Heisenberg did was he proposed that the matter has dual nature. So is a limitation to determine the position and the momentum of a microscopic particle, that is the electron, proton, etc. So what he is coming to say is that we cannot determine the position and the momentum at the same time. We cannot determine them accurately. Why? Let's see with an example now. So when we take this atomic model, the nucleus is situated at the center where the electrons are constantly moving around the nucleus. So they have some specific momentum. So now we are going to know the position of the electrons. In order to know the position of the electrons, you have to pass the electromagnetic waves with a higher frequency. Why higher frequency, we may ask. Why means the atoms are very minute. In that minute particle, the electrons would be very minute. So in order to pass through very minute particle, we need a very smaller wavelength. So in order to have a very smaller wavelength, the frequency should be higher, since the frequency is inversely proportional to the wavelength. So we are going to pass the electromagnetic radiation with higher frequency on the electrons. As we do so, we can find the position of the electron. But when we do like that, the electrons get deviated from its path. So what happens? The electrons momentum changes. So we can find only the position of the electron accurately, but we cannot find the momentum of the electron. This is what Heisenberg is saying. So in order to calculate the momentum at that time, he proposed that principle. The word itself denotes that uncertain is somewhat approximate, estimated value only, not the accurate value. So the formula is del x multiplied by del p greater than or equal to the h by 4 pi, where del x is nothing but the position of the electron and del p is nothing but the momentum of the electron, and h is the Planck's constant at a very minute value it has, and the 4 pi, we know the value of the pi, that's 3.14. so from this we can know that the more information we know about the position of the electron, the less we know about the momentum, and the more we know about the momentum of an electron, the less we know about the position of the electron. This is what he said: the more we know about the position of the particle, less we know about its momentum. And the most very important thing is that this principle is applicable only for the microparticles that are not visible to our normal eyes. If It cannot be applied to the macroscopic particle like the train bus or those we can see with our eyes. Let us see with this sum. So let me read this question. Suppose that the uncertainty in determining the position of an electron in an orbit is 0.6 Armstrong. What is the uncertainty in its momentum? So what's the value given here is the position of the electron, that's 0.6 Armstrong. Its value in meters is 0.6 into 10 power minus 10 meter. So we have to find the momentum, that's the del p. So we are going to substitute the values in the formula, that's the del x multiplied by del p greater than or equal to h by 4, and here they have equaled the values. So we are bringing the del x to the right side, and when we do so it becomes the denominator. So we get the formula del p is equal to h by 4 by into del x. The value of the h Planck constant is 6.626 into 10 power minus 34 kg m square s inverse, and the 4 into 3.14 into 0.6 into 10 power minus 10 meters. So after doing calculations we arrive at the value of the momentum, that's 8.794 into 10 power minus 3 kg ms minus 1. Okay, that's it, and then only the concept of the orbitals took place. So what's the orbitals? It's nothing but the path in which the electrons move around the nucleus. Thank you.